Hey everybody, it's Tyler here at the Lakeshore Qualifier, checking in team number 6421, WarriorBots, coming in from Muskego. And today we're going to be looking at this intake as we go through a power cell journey up into the hopper, shooter, climber, all this and more coming up on Behind.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We'd like to thank Stryker for their continued support of First Updates Now. Stryker's Internship Portal is now open and available. Discover internships and rotational programs located around the world, including their headquarters in Michigan, when you go to careers.stryker.com and click on Students and Graduates. We'd also like to thank Kettering University. Kettering University is where robotics students come for their education. Over 30% of those who attend Kettering University were in high school robotics, and you can keep going with their BattleBots, VexU, esports, and First Mentorship programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12th, 2021. So starting out with this robot here, we're going to be covering the intake. And Andy, tell me a little bit about the concept. Lots of mechanic wheels. They actually look 3D printed as well too. So
they
tell
are
me more
3D
about
printed.
that.
Yeah. So we got these are all 3D printed in our workshop. And then basically we have 2 rows of them on either side. And then this helps center the ball. And then these 2 shafts actually spin opposite of each other. So these help to center, and then this shaft pulls in with the Omni wheels. And then we have 2 pneumatic pistons up here to help pull it up and down. And then we have constant tension springs on them to help make sure it doesn't keep slamming down as often. And then it helps pull it up as well.
Do you, in a match, do you typically keep activating your intake up or down, or does it stay down the whole match?
Generally stays down the whole match, but
Sure.
if we start playing defense, we have a shield over here, we would like to pull it up.
Okay, that makes sense on there. For the intake itself, when you were looking at the mechanic wheels, like there's all different sizes and stuff. What made you choose like the small ones to go with?
Small ones just fit better with our design as well. If we lift it up, we're pretty close to the edge of the frame, so these help fit in with our inside the bumpers. And then we also tested these, and they work pretty well.
Yeah, Andy, that makes a lot of sense. So Isaac's going to be covering as we kind of go up to the next section, which is this indexer here. So Isaac, tell me a little bit more about what's going on with your indexer and any sensors or anything else you might have in it as well.
Yeah, so after the ball's gotten past the intake, we hit our first sensor right here down at the bottom. And that tells the robot that we've got our first ball. Now, the intake will keep pushing it up to our second sensor, and these are both ultrasonic sensors. So anytime there's a ball in front of them, they'll go off. Once both of the sensors see a ball, it'll increment the ball in the inner intake using these belts on the top and bottom up a ball length so that we can put another ball in through the intake. So the automatic allows for the drivers to focus purely on driving around and shooting as opposed to having to increment the inner intake at the same time as moving around.
So looking at this, are you able to store 5 power cells in this?
Yes, we can.
Okay.
We hang one down at the bottom, one up near the top. There's another sensor up here that turns off the outer intake automatically once it senses a ball, so that we don't pick up 6.
Yeah, no, that makes a lot of sense on that. It's actually what I was going to ask you on this. So one of the things I want to ask you on your belting here. So a lot of teams we've seen use kind of like that thicker polycord essentially for belting. What made you choose this type of belting instead?
I think Andy can answer that question better than I can.
So we used the belts because it was pretty convenient with translating motion from our motors. We found that the belts that a lot of people use, they slip sometimes if you're running them on rollers. So the belts timing belts just keep it consistent with our motion.
So moving on this robot here, we're going up into the shooter. You got the dual wheel type on there. So talking about some of the motors you're using and the wheels themselves and anything else that wants to go into it.
Yeah, so we have 2 shafts that are independently spinning, and they're each powered by a redline motor that has a 4-to-1 gearbox on them. And then with the indexing that we have, we can consistently feed it into these wheels once they get once they speed up.
So moving on here, we're going to go to your climbing mechanism. Tell me a little bit more about it. Does it actually activate by flipping up, or how does that work?
So we have it hooked to this Neo right here.
Sure.
And then it's chained up to here onto these sprockets, onto this chain that we have linked inside this 8020. So when we pull it up, this hook flips out and flips up, and then once we raise it up, we're at the perfect height to get onto the bar, and then we can pull down and climb.
Lastly, I want to ask you is on the blocker plate here. So I was watching you guys in a match earlier. You guys were actually deflecting some power cells and really getting in the way. So at what point did you decide that you wanted to just slap on the extra piece of polycard to make that happen?
So actually, this outer intake was redesigned. And when we were at the first 2020 competition, this was a different one and it wasn't as efficient. So we wanted to see what else we could add to make our robot better and more competition worthy. So we added this side plate so we could defend.
It seems to be working out decently well so far. So once again, WarriorBots, thank you so much for taking the time to talk to us about your robot. Good luck here at the competition. And of course in future years as well. Can't wait to see what your team produces. Thanks a lot.
Yeah, thank you so much.
Thanks to Kettering University for their support of this video. Don't just sit in class. Kettering University is the only school in the U.S. that allows you to work as an engineer your first year with their 3-month on, 3-month off co-op programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12th, 2021. We'd like to thank Stryker for their continued support of First Updates Now. Stryker's Internship Portal is now open and available. Discover internships and rotational programs located around the world, including their headquarters in Michigan, when you go to careers.stryker.com and click on Students and Graduates. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.